Well, I think we should be able to go to the boards today and you'll enjoy yourself. Okay. How acidic is it? What's the big deal? Why monitor acidity? Well, there's a lot of pictures here that kind of give you an idea. Like, you can kill your little goldfish if the pH gets too low, right? Or all fish in a lake. But I think it's just important to really monitor things, and it gives you an idea as to whether things are going wrong or whether they're going right. I mean, whether you're making beer or watching what's going on in the big junkyard there, the bioreactors. Okay. I thought this was kind of interesting in your body, right? As you increase acidity in your body. If you increase here's a good question, Kendall. If you increase acidity, does that mean the pH is going up or down? Come on, picking up. Kendall, I said pick Kendall.
Oh, you're supposed to be her first.
Oh yeah, Mia.
No, it's going up.
It's going down, right? pH goes down. And we'll talk about that. Yeah, these really low pH means that it's really acidic. Okay. And so you start out getting tired. How can you change the pH in your body? You actually can do this? What could you do? Drink a lot of something that's acidic, right? Yeah, I mean, something's going to, if you consume acidic things, you're going to be increasing the acidity in your body. Okay. Oh, there's some. Let's play around with this a little bit. That's why I brought it. Okay. So you're going to play with this in lab tomorrow, well, this week. Okay. So if I put it, this is called a pH meter, and we'll talk about pretty much what it is in lab, but essentially I just can put it in different solutions and it'll tell me what the pH is. You want to make sure the thing is calibrated first. So if I find this yellow solution, it's called a buffer solution. It maintains that pH at 7. If I put it in there, it should read a pH of 7. Does it read 7, Megan? 7.09. So pretty good, experimental error. Okay, rinse it off, put it in the buffer that says 4, and it reads 4.3. So it's pretty darn calibrated. So let's see how this works. If I put it in, here's tap water. Enrique. Acidic, basic, or neutral. Now we need to know what these ranges are. If I say acidic, or if you guess acidic, that means it's going to be less than what number? Less than what pH? He's right. 7, right? If it's basic, it's going to be bigger than 7. And if it's neutral, it should be right around 7. Okay, so Enrique, I'm going to put the pH meter in tap water. What would you guess? 7. Around 7? What does it say?
6.5.
6.5, so it's a little acidic.
It keeps going up.
It's still going up now?
Now it's 7.
Now it's 7?
It's still going up.
Still going up?
7.16.
7.16. So it might be a little bit on the basic side, huh? Okay, that's good. That's good because I can understand that. Why can I understand that? Because where are we getting this tap water from? You guys live in San Antonio, man. You got the best tap water on the planet. Where's it all coming from? Aquifer. Man, it's not even from some slimy lake with algae and stuff. No, underground aquifer. Man, people pay money for the water that comes out of your faucets. Aquifer. Well, what's the aquifer? Why are there all these holes in the ground that all this water hangs out in? What's this stuff? Yeah, what compound is chalk? Calcium carbonate. Calcium carbonate. Essentially, this is what you chew on if you buy some Tums. But anyway, the point is the carbonate. CO3 negative 2. Right? You want to make these holes in the ground. You're going to have a lot of dissolve this calcium carbonate up. Okay. Fine, Andrea. Should this generate an acidic or basic solution? Basic. Why? Where do you see a base? Exactly. Perfect. If you can see what Andrea is seeing, man, you are hanging in with this course really well. Because that means this is a conjugate base. Yeah, it's gonna be, this is in water, it's gonna be basic. So yeah, it makes sense to me that our tap water is somewhat basic. Okay, I'm going to put it in the pH meter in DI water. Now it reads what?
8.6. That's going down. 8.3.
Really? No, that one I don't understand. We gotta leave it in there a while. Because DI water, oh, it's going down to 7.8 now. Maybe it's just gonna take a while. 7.6. DI water should be acidic because DI water, what does DI stand for? Deionized. That means there aren't any ions. Well, what ions are in tap water? Here's two of them right here, right? So that means this stuff isn't in deionized water. It replaced all of these with hydrogen ions. So DI water should be roughly, it should be acidic. But I was told our DI system isn't working so well, and well, maybe it's not. Maybe our DI isn't so DI. Okay, and then I got, what else did I get here? Oh, Andromeda gave me some, what is this? Red Bull. Starbucks Red Bull. Cameron, what would you guess? Acidic, basic, or neutral? Why? I would have guessed that too. Acidic. There, you see the little bubbles in there, right? What's the bubble? What gas is the bubble? Carbon dioxide. If you dissolve carbon dioxide in water, you really get this. Oh. So Kenneth, that means anything that's carbonated should be acidic, carbonic acid. So it should be acidic. Let's see. I mean, that would make sense to me. But they put a lot of other stuff in there. What does it say?
3.4.
Oh my gosh,
It's
yeah.
going down.
It's still going down. That's why you should probably brush your teeth afterwards, right? Probably more for the sugar, though, than the acidity. Oh, let's see. I have Pepsi. This Pepsi's really old, though. There isn't any carbonation left. I don't know what it's going to be. I pulled this off the shelf. I'm surprised it doesn't. I don't know, I guess this stuff doesn't get moldy. I mean, it's been in the shelf for years. What would you guess? Jose, what would you guess? Acidic, basic, or neutral? I don't know, I guess. 2.8. Yeah, that stuff, I guess it doesn't get bad, ever. Okay. So, that's that. I should probably put the cap on this so stuff doesn't spill. Since you guys are going to be going to the boards and having all this fun, helping each other out. Because it's really calculator play. You're going to find out today, I think, is really just calculator play. And if you can figure out how to use that calculator, you're going to be good. Oh, we can answer these. You can fill them all out. Connor, neutral solutions have a pH of 7. Next one, Enrique, acidic solutions have a pH less than 7. Basic, greater than 7. Right? Okay. Self-ionization of water. There always exists an equilibrium between water and its ions. How would you write that reaction out, Steph? Water goes to what plus what? Yeah, H plus OH. I wish you'd have charges on there, though. H plus and OH minus. Good. Okay. What is the equilibrium constant expression for this reaction? Megan, big K equals what over what? On top or bottom? On top. Good. Over H2O in brackets? Oh, now she says no. Because you saw the L. Good. Over 1. There it is. Okay. And the equilibrium constants that are kind of special and that you have to write the reaction a certain way, they always give a subscript. What's the subscript on the K for this reaction? Does anybody know? W. And that number at 25 degrees, this part you don't really care about. But remember, that's the only way to change the equilibrium constant, is to change the temperature. But anyway, it's 1 times 10 to the negative, anybody know? Yeah, 14. If you played this game before, you know you'll use that number a lot, and you'll have it memorized. Kw is 1 times 10 to the negative 14. Would you say that equilibrium constant, oh, who am I picking on here? Andrea, is a really big or a really small number? Yeah, extremely small, right? Almost a millionth of a billionth. So pretty much in pure water, all you have is H2O liquid, okay? You don't have the ions there. Very, very small extent. Helpful hints to predict the pH of strong acid-base solutions. So we're going to predict is kind of a nice word. We're going to be calculating this stuff. But I guess in the calculation, you're predicting it. So what will really help? What will really help is to first know the formulas of the 6 strong acids. If it's a strong acid, then you'll know what to do, how to get the pH. Bowdy, what were the 6 strong acids again? Just the formulas. Remember what they were? 3 of them were the easy ones. What were the 3 easy ones? HCl, HBr, and HI. Okay, perfect. The 3 hard ones, Kenneth. HClO4, HSO4, and HNO3. Okay, there's only one thing wrong. Does anyone recognize it? 2SO4. Perfect. Really close. Sulfuric acid. The sulfate has a negative 2 on it. The formulas of the strong bases. Ooh. Cameron. Now, you didn't have me for who had me for Gen Chem 1? Anybody? Okay. Kenneth did? You didn't have me for Gen Chem 1. You guys did. Okay. For you guys who had me for Gen Chem 1, I harped on only one solubility rule. I didn't have you memorize them, but I harped on one of them. What was the one? Now, solubility rule is, oh, if this is in solution, it always breaks up 100% into its ions. What was the one solubility rule that I said that you should know? That it solved so many problems, you just had it memorized. What was it? You remember? You put these ions with anything, and it always dissolved. You always broke it up. The alkali metals, group 1. So put a group 1 metal with hydroxide, and you should have a what base? Strong base. That's all you do. So lithium, sodium, potassium. I mean, go all the way down the list. Lithium, sodium, potassium. But is that all? No, look at that. Okay, you've got rubidium and cesium, but those really aren't you're not going to see it. But calcium, strontium, and barium you will. So they're also in there. But notice how they have a little subscript of 2. Whoop. And we'll play around with that before you leave class today. Okay. So these guys always dissociate 100%. Okay. Well, what does that mean? That means that if I have 0.12 molar NaOH, what's my hydroxide concentration? It has to be nothing to calculate. Dissociates 100%. Has to be that number. That's why you know this strong stuff, because then you can do the easy ones. Okay. Now the hydrogen ion, you're going to have to calculate it, and we're going to show you how. But the point is when they give you the concentration of a strong acid, you know the concentration of H plus then, right? When they give you the concentration of a strong base, you know the concentration of the hydroxide. So that's key. If you don't know what's strong, man, you're screwed, right? So you got to know those strong acids and those strong bases so you can knock out the easy questions. So, for example, for this one, then what's the concentration of hydrogen ion? Well, you're going to have to calculate it. Pick your equation, right? If you know the concentration of hydroxide, you can get the hydrogen ion concentration. And in fact, there's two ways to find the hydrogen ion concentration. That's what this first question is. And you can get it from, it looks like, Kendall, you can get it from equations 1 and 4. Ooh, you get the fun one. Let's start with the fun one to get it over with. How would you solve for hydrogen ion concentration then? So I guess here is the case where they would have told you the pH. The pH is some number, and they say, okay, what's the hydrogen ion concentration? They told you what the pH is. How would you solve for hydrogen ion concentration in that? How do you get rid of log? You do what to both sides? To the 10, right? It's not little e. It's not little e because it's not ln, exactly. Okay, see, I think you're starting to remember. So you raise both sides of the 10 power. Okay, so now what I would do, though, is bring that negative sign over first. I would have negative pH equals log. So you don't need to do this every time, you just so that you can see it. So I'll have 10 to the negative pH equals 10 to the log H plus. But those 10 and the log are inverse functions. They're just going to cancel out on you. So you get 10 to the negative pH is equal to the hydrogen ion concentration. That's the expression. 10 to the negative pH equals hydrogen ion concentration. But notice that equation's not up here. So you have to be able to rearrange that and get there. Okay? So that's something that you need to be able to realize. How to solve for hydrogen ion concentration. So you can get it from equation 1. When they give you pH and that's some number, hey, what's the hydrogen ion concentration? Solve for it. How do you do it? Right here. Well, they say equation 4, that was equation 1. Equation 4, you can also get the hydrogen ion concentration. Kw is 1 times 10 to the negative 14 equals hydrogen ion times hydroxide. That looks a lot easier, I think, Jose. How would you solve for hydrogen ion there? Do what to both sides? All right. Want to help them out? Yeah, you got to solve for this one. So I would divide both sides by that OH. So your hydrogen ion concentration is going to be that 1 times 10 to the negative 14 all over hydroxide. So they would have to give you the hydroxide concentration. And you divide it into 1 times 10 to the negative 14, you'll have hydrogen ion. Okay. So you have to know how to rearrange those guys. It's the same story for the hydroxide, right? Do that now. You do this. Rearrange equation 2 for hydroxide. Rearrange equation 4 for hydroxide. And then I'll ask you. Connor, how did you get, what'd you answer for the, if you rearrange equation 2 for hydroxide, you came up with hydroxide equals
10
POH. Isn't that weird, POH? I mean, this meter, he doesn't read POH, he reads pH. Well, how would you get a POH? Well, there's an equation up there that would give it to you, right? If you ever needed POH, you just subtract pH from 14 and you can get POH. Kind of weird. Okay. How about rearrange equation 4 for hydroxide? Enrique, what'd you come up with? Yeah, see, it's not so bad. Plugging in the calculator might be something else, though, but. Okay. So try it. See if you can get answers for both of these. The hydrogen ion's 3.8 times 10 negative 3. What's the pH? If pH is 2.85, what's the hydrogen ion? Find the right equation for what you're looking for, right? Like this first one is just, hopefully you're picking pH as the negative log of H. And get an answer. Straight in the calculator. Oh, there's another one. See if you can do D also. I give you pH, so you can find hydroxide. That's about as complicated and ugly as it's going to get. See if you can get these. I'll write the answers up here and see if you can get them on the calculator. See if you can get those. And if you're not getting them, let me help you out on the using those calculators. All right. Yep.
I don't put this on the calculator because
The top one?
No, the bottom one.
The bottom one.
It's,
So I would do this part first, and then I would give you the hydrogen ion concentration.
yeah, but I can't get.
And then, oh, how do you do this? We'll do 2.85.
I tried. They won't put the point in.
No, just do 2.85, and then make it negative, and then do shift 10 to that power, 10 to the x.
Okay.
So if you're having trouble getting any of these, man, ask. Okay, which one? The first one? Okay, the first one should be, all you do is plug in 3.8 times 10 negative 3, put that in the calculator. Whoop, 3.8 times 10 negative 3, and then take the log of it. So put in 3.8 times 10 negative 3. Yeah, and then the log, log. There it is. And it's negative. See, the negative sign cancels out. So you have to multiply times the negative. So you really just get 2.42. So make sure you can get all three of these. And then we'll go on. We'll go to the boards. The second one? Okay, the second one, if this is, what is the pH? Okay, so we have to raise, oh, yeah, just plug it right in. So we'll put 3.8 times 10 to the negative 3 in for this, push the log button, and we'll have it. So put in 3.8 times 10 to the negative 3, exp, 3 negative, and then just push log.
Oh, you don't do shift log?
Nope, because shift log would be 10 to the x.
And for this one,
Now this one I would do 2.85 first, right? I would do 2.85, make it negative, do the plus minus guy. Okay, now you want it 10 to that power. Now you do shift. Okay, now that is hydronium. And then you can put that in, where's that equation? Right here. Put that in for this guy, right? And then you take 1 times 10 to the negative 14, divide it by this, whatever you got, and you'll have your answer. So there's a couple of ways to do C, right? Because you could have found POH and then raised 10 to the negative POH. That would also work. Subtract 2.85 from 14 and 10 to the negative POH. Oh, that's hydronium. We don't want to do that. Maybe down here for D you could do that. Let's see. So you took 8.35, 14 minus 8.35. Okay, so that your POH was 5.65. Okay, and then make it negative. Shift 10 to the x. You get 2.2 times 10 to the negative 6. Oh, I got 2.4. How did I do that?
I got 2.24.
Yeah, maybe that should be 2.24. Because it doesn't matter. Either way you do it, you should get the same answer. Okay. So everyone's comfortable with their calculator? All righty. So we can knock these out and we can call it a day. We'll go to the boards, and we got several of these questions. They'll slowly get more difficult. So we just want to start out with the easy ones and make sure that everyone can do them. So just write your answers to these.
Why is he just cutting each one? Can I stick my hand under it?
Mm-hmm. Whoa.
What is that?
It's a little magnet.
Oh,
Nothing happens. You guys want to go to the boards? So lazy. Fine. Write your answers. What's the hydrogen ion concentration of 0.25 molar HCl? Everybody. 0.25. What's the hydroxide concentration, Steph? Or you're busy. You keep helping Mia. Andromeda. What's the hydroxide concentration in 0.15 molar NaOH? 0.15. What's the hydrogen ion concentration in 0.15 molar NaOH? Andrea, how would you do this? Yeah, what would you plug in? Good. 0.15 would be for the OH, so then you'd do what? Right? Yeah. Exactly. Take the 1 times 10 to the negative 14, divide it by the 0.15, and you'll have your answer. How about D? How would you do D? Bowdy, how would you do D?
pH of 0.05. You could solve for the
Yeah, there's kind of an easier way though. You know, she's saying you could solve for the hydrogen ion concentration, but there's a lot of stuff to plug in the calculator. Do you see an easier way? You know this is find POH, then subtract it from 14. That's kind of easier, right? There's a lot less stuff to plug in. See what I'm saying? Just find POH. So take the log of 0.05, and when you put it in the calculator, it's going to come out negative, so you pretty much just add it to 14. Try it. All right? Find the POH, put it in the calculator, 0.05, the log, you get a negative 1.3. So the POH is really 1.3, but you got subtracted from 14. So pretty much just add whatever you have in the calculator to 14. You get about 12.7. Right? Okay. So they're going to slowly get more complicated here. See how many of these we can get through.
What's the smaller big M for like A and B?
Yeah, all concentrations are big M. pH and POH have no units. Yeah, pH and POH have no units. Mm-hmm. Yep, but don't forget your units. It has to be big M. And that's the concentration of which one? What is this?
Oh, HBr.
HBr. So that's going to be the concentration of
H.
H plus. And really they want H3O plus, but they're the same thing. So where are you at, Mia? How'd you do this? How'd you do this one?
I didn't do it at all. That's why.
Yeah. So how would you do it?
I would do this one.
You'd want to, but you can't forget the all those strong acids that we listed out. Remember, if this compound is a strong acid, there's nothing really to calculate, and they're asking for. If you said you want to do this, that means you're calculating pH. But they didn't want to know pH. They just want to know what the concentration is. And when they're strong acids, you know what the answer is. It's just 0.25. So the bracket is this thing. The bracket, I guess what helps me is to remember the brackets always have what units?
Big M.
Big M. Does pH and POH have any units? No. That kind of helps me. So if I see a big M, I know that it's got to be either hydrogen ion or hydroxide is what they're talking about. Oh, and H3O plus is a fancy way of writing H plus. They're the exact same thing. So you can almost as well cross it out and write H plus, but the homework is going to throw that at you. That's in 15.53. Hydronium, H3O plus, is the same as H plus. So how would you do this one?
Do it like this one.
They want to know what hydroxide is. So don't feel pressured to have to use this stuff. You see what the question is first and recognize this is when they told you HCl, that was a strong acid. So you have no idea what hydroxide is, but you know H plus. So if they would have asked for hydroxide, well, I can't get the answer from here, then you go up here and calculate it. So look and see if you have the answer first. Like here, they're asking for hydroxide, and you know what hydroxide is because it's a strong base.
Yeah.
So this is it. You're done. Now, if they would have asked for hydrogen ion, then you would have had to come up here and use something because you can't get that from this. So hopefully for these, you should be getting answers like it's 1.2 molar, right? Let's see, 1 times 10 to the negative 14 divided by that. About 8.3 times 10 to the negative 15. Right? And it kind of makes sense because if it's a strong acid, you should have a lot of H plus, but hardly any hydroxide because it's a very acidic solution. So it is. It's really, really tiny, the hydroxide concentration is. It's really, really tiny because it's very acidic. See if you get this answer for 77. 4.3 about times 10 to the negative 3. You should be able to get that for that one. You can. 10 to the negative pH is hydrogen ion. And then once you get that, you can plug it into the hydrogen ion expression. Then you'd know this one, you could solve for that one. But we know what's kind of easier for me is to get POH. If I know pH, subtract this from 14 and get POH. Could you see that equation? pH plus POH is 14. And then I can just 10 to the negative POH is hydroxide. But either way works. Either way works.
So how would I do example?
Good. Okay. So if you're not there yet, I would check out EX1. I think this is as ugly as it's going to get in the homework, is EX1. All right? Does anyone have a clue how to do it? Oh, yeah, okay. Because we want to know what pH is, and pH has to do with concentration. How do you get concentration? Not grams by liters, but moles by liters. Get this into moles. Right? Then divide it by the liters, and you'll have the concentration of OH. And then it's just like one of the other problems you've done. Right? They're after pH, and you know hydroxide. I really like using this, whenever I can, I like using this equation pH plus POH is 14. It really speeds things up for me. But so since you know hydroxide concentration, I would probably find POH, take the negative log of it, and then just subtract from 14. It's just easier to use that expression. Let's see if you can get EX1. See if you can get an answer for it. Yes. Has to be moles over liters. So this has to be in liters. I got a final answer of around 13.4. EX2 is also has a twist to it
So like the base weight would be the concentration
of
hydroxide.
the hydroxide.
Yeah, so then that's how you.
Yeah, then I took the negative, took the log of it and got POH, and then I subtracted from 14 to get pH.
Okay. Oh, okay. Because you have this.
And with a little bit of time we have left, if you can read over EX2, because that'll give you a hint how to do that type of problem. And pretty much they're just dumping HCl with HCl, or they could be dumping NaOH with NaOH. But the point is, what you do is just figure out the total number of moles of strong acid, add them up, divide that by the total number of liters, and you'll have the final hydrogen ion concentration. So, and remember, big M is really what over what? Moles over liters. So I can get moles by converting this into liters and just multiplying it. So I can get the moles from this solution, right? Get the moles from this solution. Get the moles of H plus from this solution and add them up. Okay. Your total number of liters should be like, what, 0.25 liters plus 0.25 liters. Okay, so they're not too bad. I'll be glad to help you out.
Even though it's HCl, it's just H+.
Yeah, and the reason why this works is because it's a strong acid. So the Cl doesn't really matter. You know, it's H plus is what we're interested in. So have a good day. Stay warm.